Hello student, this is my fourth class from Electrostatics. In my previous classes, I discussed mainly theory, but today I shall focus the problem and question, different type of problem and question related to the topics which I discussed in my previous three classes. Okay, you see that to solve the problem or question any type, to solve it you have to know the basic idea behind it, the basic idea of the theory behind it, that is discussed in various lectures. So at first you go through the lectures of my previous lectures and then you can easily solve the problem. So come to the point. Here look at the board. There are 6 problem or question mentioned on the board. Now look, the first question, find out potential at the origin O and field. Look, this is the x-axis. Here at a distance 1, 2, 4, 8, 16, okay, equal charge are placed and same nature. Suppose all are in SI system. You have to find out potential at O, okay, and electric field. Now, in my third lecture, I proved that potential at a distance x from a point charge equal to 1 by 4 pi epsilon naught q by x in SI system, okay, in vacuum. Now, so question number 1, solution. Look at, so potential V equal to 1 by 4 pi epsilon naught q by 1 plus q by 2 plus q by 4 plus dot 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 infinity. Now if you take q out, q by 4 pi epsilon naught 1 plus 1 by 2 plus 1 by 4 plus dot dot dot. Now follow, this is a algebraical formula, 1 plus half plus common ratio half. So final result will be, here we write the final result equal to q by 4 pi epsilon naught 1 by 1 minus half. Common ratio, first term 1, 1 minus, this is a formula, okay, 1 by 1 minus half. So final result will be 2q by 4 pi epsilon naught. Clear? So potential we can find. Similarly, if you have to find out the field, then what will be there? Note it at first. In case field, follow, E equal to 1 by 4 pi epsilon naught q by r square, 1 square, 2 square, 4 square, then 8 square. Similar way you can find out the result. Clear? Look, electric field q by 4 pi epsilon naught 1 plus 1 by 4 plus 1 by 16 plus 1 by 64 dot dot dot. Here similar way you can find out the result. First term 1, common ratio 1 by 4. So the result will be similar way you can reach the answer. Okay, note it. In this problem slightly change. If, note, question number 2, if alternate charges are negative. So first problem already completed. Here we find out the potential and electric field, but you have to know the formula. 1 plus half plus 1 plus r square plus r cube, common ratio r, so result will be sum will be 1 by first term 1 by 1 minus r. Clear? If the alternate charges are negative, follow this q minus, this q minus, this q plus. First q positive charge, second minus, third plus, next minus. If alternate charges are negative, what will be the potential? Clear? Second question. What will be the potential? Similar way, we can find out. Question number 2. Potential V equal to, similar way, follow Q by 4 pi epsilon naught 1 by 1 minus 1 by 2 plus 1 by 4 minus 1 by 8 plus 1 by 16 minus 1 by 32 and so on. Clear? Follow two different series. Look at Q by 4 pi epsilon naught potential, that is 1 plus 1 by 4 plus 1 by 16 dot dot dot, first series, minus common half minus half common, the result will be 1 plus 1 by 4 plus 1 by 16 plus so on. Follow, this is the two series here and here. Similar way, the result will be 1 by 1 minus 1 by 4 here also, and the final result will be final result V equal to Q by 4 pi epsilon naught. Clear? This will be the final result. Sorry, 6 Q by 6 pi epsilon naught. No need to further calculate it. Similar way, you can calculate this. If I calculate it again, time loss. Okay, follow. You can easily will reach the answer. This series and this series. Third question. This type of question I discussed in my second lecture. Okay, where I discussed Gaussian theorem, application of Gauss's theorem. Here, this is y-axis, this is x-axis, this is origin, this is a thin sheet, charge density plus sigma, this is a thin sheet, charge density minus 2 sigma, this is also a thin sheet, minus sigma. Follow, this is the charge density. The distance, x value of y minus a plus a to a. That is this distance to a, this distance a, this distance downward, that is minus a. So what will be the field at P? Follow it. What will be the field at P? We know this is plus. So here the direction of field in this way. Clear? Flux coming out from positive charge. Here the field negative, that is field direction due to this place. Clear? Here also direction this. So here total at the region P, total field, follow, total field for thin sheet, we know in my application of Gauss's theorem, field intensity of electric field equal to sigma by 2 epsilon naught for the first, second, plus 2 sigma by 2 epsilon naught plus sigma by 2 epsilon naught. Follow. In this P region, total field for the three sheets in the same direction. Clear? That is why we add. Now, if we add 2 epsilon naught 4 sigma, that is 2 sigma by epsilon naught. What will be its direction? Downward. In my second lecture, application of Gauss's theorem, it is proved that due to a thin sheet, the field at the nearer point will be sigma by 2 epsilon naught, that is thin sheet, and for thick sheet, sigma by epsilon naught. In vacuum or air, this negative sign and this is negative sign, but in case of field, only we have to note the direction of the field. Clear? Positive, negative. Flux coming out from positive charge and flux terminate to the negative charge. Note it. My next problem, find out number of flux coming out from 1 coulomb charge. Here we can apply Gauss's theorem. Find out number of flux coming out from 1 coulomb charge. Okay, now from Gauss's theorem we know total flux phi equal to Q by epsilon naught. Clear? In vacuum, find out number of flux. Q means 1 coulomb, epsilon value 8.85 into 10 to the power minus 12. So you will get the result approximately 1.2 into 10 to the power 11 Newton Coulomb to the power minus 1 meter square, Coulomb to the power minus 1. This is the unit of flux in SI system. Clear? You note that in every problem or question, all the solution depends on the basic idea of theory. Clear? Very easy. Next question, very important point. At what distance from the center of the ring? Follow. This is a uniformly charged ring. In my first lecture, I find out the electric field at a distance x from the center of a ring, and it is also discussed potential in my third lecture. Okay, so now we have to find out at what distance from the center of a ring the electric field will be maximum. Electric field will be maximum. Follow. Electric field will be maximum. In my second lecture, due to a charged ring, this is the distance x and this point P. Due to a charged ring of radius r, at a distance x from the center, we know the field 1 by 4 pi epsilon naught q x by x square plus r square whole to the power 3 by 2. Follow. from my second lecture. Okay, note it, from my second lecture, the electric field due to a ring from at a distance x from the center, we proved it. Okay, electric field maximum. Now x, if we differentiate electric field with respect to x, what will we get? Very simple differential equation. Now x plus minus 3/2, we can write in this way. You may solve it in another way mathematically. Maximum field is maximum, that is derivative of b is equal to 0. That is, next line we can 0 equal to this form do. Now derivative of the first term x, derivative of x 1, second term constant, plus this term constant, second term derivative, minus 3/2 into x square plus r square to the power minus 5/2 into 2x. Follow. Very simple differentiation. Okay, if we differentiate, we get, and then take common x square plus r square to the power minus 5/2. If we take it outside, the result of x equal to, we get r/√2. Okay, very important question. In MCQ also, there this type of question may set that for a charge ring of radius capital R, what will be, at what distance from the center the electric field will be maximum? Option A R, option B r/2, option C r/√2, option D r/√3. So you have to know that the result r/√2. So for broad question you have to prove it, and from short question you have to know the result. Okay, clear? So number question 5, we solved it. We know from this equation, at the center of the ring, if x equal to 0, e equal to 0. So at the center of the ring, field is 0. Okay. So what will be the graphical representation of the field versus distance due to charge ring? Follow. Electric field in y-axis, and this is positive x, this is negative x. Follow. This is positive x, this is negative x. At the center 0, at a distance r/√2, suppose. Follow. Here r/√2, here also r/√2. Very important. At the center, this is the origin O. At the center, field is 0, but at a distance r/√2 maximum, then field decreases in this way. At the center 0, at r/√2 maximum, then decreasing. So this is another important question, graphical representation. Clear? Now look, question number 6, another very important question or problem. Now find out field at P. This is a metal thick cell, metallic thick cell. Clear? This is the thickness. This is the thickness. Okay, this portion thickness. Inside the cavity, a sphere of radius smaller and charge plus q is placed at the center of the cavity. Find out field at P and Q. Inside the cavity, a charge sphere of radius r is placed. Inside the cavity, a charge sphere of radius r is placed. So what will be the field at P and at Q? Very important question, and you will get the new idea from this problem. Clear? At P, suppose the distance of P from the center means O, OP equal to x. So according to Gauss's theorem, if we draw a Gaussian surface, okay, this distance equal to suppose x. So if we draw a Gaussian surface, E equal to Q by x square 1 by 4 pi epsilon naught. Clear? This is positive charge, so the direction will be radially outwards. Simply we apply Gauss's theorem. But this in the metallic region at Q, follow, at Q plus Q, sorry, this point Q, here Q, R. At the point R, this is the inner surface of the metallic shell and this is outer surface. So due to induction, nearer surface negative charge and outer surface plus charge. Follow. This surface get due to induction negative minus q and this is plus q. So this R region, follow, if you draw a Gaussian surface through R, you follow inside the Gaussian surface total charge plus q and minus q 0. So field at R equal to 0, because inside the Gaussian surface the total charge plus q and minus q, that is 0. If you have to find out the field at a distance outside the sphere, this point S here, then follow total charge plus q, here minus q plus q, total charge plus q. So here the result will be, if this distance is y, the result will be 4 pi epsilon naught q by y square. Clear? So from this problem we get the basic idea, application of Gauss's theorem. So in short question, if this type of question, a thick metallic cell, what will be the field at the metallic region? So the result will be 0. Clear? Next question. Similar type of question. Okay. Follow. A charged ring. Next question is charged ring. Just charged ring of radius r. Follow. A charged ring. Question number 6. Charged ring of radius r and the lambda equal to charge per unit length. Charge per unit length. Lambda be the charge per unit length. Okay. Total charge suppose plus. Follow. If at the center field will be 0, but here is portion cut. The portion length of the portion dl. Dl portion is cut. So what will be the field at P? Follow. The field at P due to complete ring, this point, there are a pair of opposite point. Due to this, field cancel each other. The total field at the center due to whole ring is nil. In my 4 or 3 question number, in my question number 6, I discussed. But here cut. So here total charge here. Total charge in dl, lambda dl. So this due to here is a point, similar point here. So due to complete ring, this point at this point, due to these two pair of opposite point, the field is cancelled here, but here is no charge. So the field will be at the center will be equal to 1 by 4 pi epsilon naught. Total charge here lambda dl by r square. Follow. No charge here, but I take lambda dl. In the opposite side here, similar point consider. This is dl. So total charge here lambda dl. Total charge here lambda dl, but it is cut. So this lambda dl cancel each other, but here is no lambda dl. So field will be created here due to this portion and the direction in this way. Clear? Because it is positive charge towards this direction. So equal to 1 by 4 pi epsilon naught lambda dl by r square. If you put the value of lambda, then total charge suppose q. So lambda equal to q by 2 pi r. If the question here lambda is a charge per unit length, then this is the expression. If total charge q, then you have to put the value of lambda here. Clear? Again I mentioned this field is created due to this portion, not this portion. That is why the direction in upward. Okay? Very important question. My next item, next problem, question number 7. Okay? Note it. Question number 7. Here. Two spherical cell, concentrated spherical cell. Look at the inner radius smaller, outer radius capital R. Two concentrated spherical cell. Two concentrated spherical cell of inner radius R and outer radius. The charge of inner radius small q and outer radius capital Q. Charge of inner radius small q and outer radius capital Q. Suppose both the charge plus q, positive, maybe negative as you like. What will be the potential difference between the two cells? Find out potential difference between Suppose inner one A, outer one B. Between A and B. This is the question. So at first, follow the question. Two concentrated spherical cell of radius inner one smaller, outer one capital R. The charge of the inner one plus Q, outer one plus capital Q. The inner sphere is considered as A and outer sphere B. So find out potential difference between A and B. Look, in my third class lecture, we have proved that due to a spherical cell, the potential from center to surface everywhere is same. You must follow in my third class lecture. So potential of A cell, that is VA, potential of A, potential due to same self charge 1 by 4 pi epsilon naught Q by smaller due to its own charge, but plus Q for 1 by 4 pi epsilon naught Q by R. Follow. Inner one for his own charge Q 1 by 4 Q by R, but due to outer sphere, due to plus Q charge from center to this, the potential Q by R. Now the potential of outer sphere due to its own charge 1 by 4 pi epsilon naught Q by capital R plus, but here plus Q charge, this due to plus Q charge Q by capital R. Follow. Potential of the outer cell due to its own charge and due to Q charge. We know if a charged sphere of charge Q, then the potential at every point inside 1 by 4 pi epsilon Q by, but at a distance R 1 by 4 pi Q by R. If we VA minus VB, then we get the result VA minus VB. You will get the potential difference between two cells. Follow this cancel. If we VA minus VB, this cancel. So result will be 1 by 4 pi epsilon naught Q 1 by R minus 1 by R. Clear? Understand? Next question number 8. Follow. A cylinder, look at a cylinder, big cylinder, a big cylinder volume density of the charge, the cylinder volume density of charge equal to rho. Suppose volume density of charge rho. Inside this there is a small cylinder, same axis. Follow. another cylinder. The length of the cylinder L. You have to find out field at a distance x. This is P point. Clear? At first, follow the question. A big cylinder, charged cylinder, uniformly charged, volume density of charge rho. Of course, this is a non-conducting solid, because if the conducting, the total charge resides on the surface, so no need to arise this type of question. So question again, note, big cylinder, volume density of charge rho, inside a small cylinder of length L and radius x. At a distance x at P, you have find out the field. If we apply Gaussian system, this is the Gaussian surface. So E dot ds equal to Q by epsilon naught. This is the Gaussian theorem, Gauss's theorem. From this, E follow the direction of E in this way, and ds is also in this direction. So E dot ds equal to E ds cos 0 degree, that is E ds. E into what is ds? ds equal to total charge, the volume of this inner cylinder, pi r square into L. Volume of the inner cylinder, pi r square L, pi r no, x square L into rho, total charge by epsilon naught. Follow it. Again, next line, E into what is the curved surface? We know this field. Here flux 0, here flux 0. So in my second class lecture, in a cylinder, flux through the plane surface nil, because E and ds is mutually perpendicular to each other. So E into the curved surface area 2 pi x into L equal to pi x square L rho by epsilon naught. So from this equation you can get E, the result of E, that is pi x square L rho by 2 pi xl epsilon naught. Follow this. This is the result. Okay, you get the result. Question number 8. Total charge, the volume of the inner pi x square L into rho, volume density of total charge by epsilon naught, the area of the curved surface 2 pi xl. From this equation we get the result of E. Now problem number 9. Electric field is given by 1 by x square I volt per meter, that is in SI system. Find out potential difference. Between points x equal to 10 semi and 20 semi. Follow. At first note the question. In an electric field, E is given by 1 by x square I volt per meter in SI system. Find out potential difference between the 2 points, between the points x equal to 10 semi and x equal to 20 semi. Clear? We know it is discussed in my third class lecture, E equal to minus dV by dx. That is E equal to dV equal to minus E dx. So potential difference between these 2 points, V equal to integration of minus E dx from 10 semi, if we convert into meter, so 0.1 to 0.2. Follow. Lower limit 0.1 meter and upper limit 0.2 minus 1 by x square dx 0.1 to 0.2. Follow I in the direction of x-axis. Here the point in the direction of x-axis. So no problem. Same direction. If we calculate, the result will be minus 5 volt. Very simple. The result will be minus 1 by x, minus a plus, upper limit and lower limit, we will get the result. Follow it. Next question. Question number probably 10 or 9. 10. A cube. We consider a cube. Follow. This is a cube. Each of its vertices equal charge plus q or minus q as you like. At 4, 8. Follow question. The side of the cube, suppose A. A cube of side A and each of its vertices equal charge of plus q are placed. So find out the potential at the center. Find out potential at center. Clear? Find out potential at center. Follow the diagonal of the cube a root 3. So for every corner, the distance, every corner of the cube, the distance of the center equal to a root 3 by 2. Potential is a scalar quantity. So total potential at the center V equal to 1 by 4 pi epsilon naught q by distance a root 2 by 2, but 8 charge, that is 8. This is the result. You can easily simplify it. Okay, that is, we need not mention the direction because potential is a scalar quantity. For one charge potential 1 by q by distance, so 8 charge. Clear? You will get the result. And in, of course, SI system in vacuum. If instead of vacuum there is another medium dielectric constant K, there is K epsilon naught. Clear? If instead of potential you have to find out the field at the center, of course the field will be 0, because at each diagonal opposite corner same charge and equal charge, equal nature. So due to the pair of charges the field will be nil. That is why total field will be nil. That is every pair of charges. So field will be nil at the center. Another question: what will be the electric intensity of electric field at the center of a cube if at every corner equal and same nature of charge is placed? So field is nil at the center. Clear? Now next question, number 11. This is a square. Four equal charge, plus Q, plus Q, plus Q, and plus Q. This is the two diagonal. This is the center O. What is the question? Find out work done. Work done to remove. Work done to remove minus Q charge from center to infinity. Follow. Minus Q charge, work done to remove minus Q charge from center to infinity. So at first you have to find out the potential here. Total potential at the center, suppose VO equal to, at the center VC we consider 1 by 4 pi epsilon naught Q by, if the side A, then A root 2 by 2. Follow? This is A root 2 and this distance A root 2 by 2. Multiply 4 due to 4 charge. So total potential here and infinity, potential at infinity equal to 0. So potential work done to bring the charge from this point to infinity. So potential difference between infinity to the center, total work done into charge, that is minus Q. This is the work done. Clear? So total final result, what will be the final result? Final result will be minus, and here means you put the value V infinity 0. Why we take this V infinity minus Vc, not Vc minus V infinity? Because in my definition I mentioned that work done, potential difference between A to B is work done per unit positive charge to bring it from B to A. Okay. Another important point, in the definition of potential, it is said that potential in an electric field, potential at a point in an electric field is defined as the work done per unit positive charge, test charge, to bring it from infinity to that point. To bring it, but how, in what way the charge will be brought? With acceleration, with retardation, with uniform velocity? Of course with uniform velocity. No acceleration, no retardation. It is a MCQ short question. to bring the charge from infinity to that point with uniform velocity. Okay, so we get the work done VL infinity minus VC into charge W is equal to VQ. My next question here, question number 12. You have to find out the here plus Q charge A, B, C. Suppose this point is D. You have to find out the electric field at D. If the question such type, you have to find out the electric field at D. Due to this charge, the direction in this way, due to A, due to C, the direction in this way, and due to this B charge, the direction of field in this way. This angle 45 degree, this angle 45 degree. So the A, so total field due to this field here 1 by 4 pi epsilon naught Q by A square. This is also 1 by 4 pi epsilon naught Q by A square, and this is 1 by 4 pi epsilon naught Q by A root 2 whole square. But field is a vector quantity. So these three vectors in different direction. At first, these two vectors, resultant of these two vectors, suppose this is E and this is also E. So resultant of these two vectors will be root over E square plus E square equal to E root 2. Follow. And this E root 2 is directed in this way. This field E, magnitude equal. The total field due to these two fields in this direction, root over E square plus E square. Vector addition law, parallelogram law of vector addition. Here is 90 degree. So total result, suppose this field E1. So total field at the point D equal to total electric field equal to E root 2 plus E1. You put the value and get the result. The direction will be towards D P, suppose in this direction. So we get the another question from here. Clear? Force, if we have to find out the force at D on the plus Q charge, force equal to field into charge. You get the result. Now next question, a half ring. Follow. This is a half ring. We know that due to the charged ring, this is plus charge plus Q or charge power unit length lambda. Charge per question number 12. Charge per unit length equal to lambda. The radius, suppose the radius R. If the full ring, field intensity of electric field 0, but due to half ring, this is line, here we take a small portion, that is dl. This angle theta, this angle d theta. this is R. So due to this small portion, the field will be in this direction, that is E. Take similar way, from here we consider another similar point. Due to this, the field will be in this direction E. So that is, this is theta, this is theta, this is also theta. So total E sin theta cancelled each other. Total result E 2E cos theta. Clear? At first, note the so total field, electric field at the center 2E cos theta, that is 2 into E means lambda dl, charge for lambda, dl in dl length total charge lambda dl by 4 pi epsilon naught r square, this distance r radius, into cosine of theta. Now follow 2 by 4 pi epsilon naught r square lambda, follow dl, this triangle, this small triangle I draw here, this is d theta, this is dl, this is r. So dl equal to r d theta, dl equal to r d theta. Here r cos of theta d theta, these are cancelled. So total electric field 2 lambda by 4 pi epsilon naught r integration of cos theta d theta from 0 to pi by 2, total 180 degree, but lower portion is cos theta, upper portion is cos theta, that is why 0 to pi by 2. You can easily integrate it, cos theta integration sin theta, and you will get the result. Lambda by 2 pi epsilon naught r. Clear? So half ring we get the result. If instead of electric field you have to find the potential, so very easy potential, no need to mention the direction, just like scalar quantity we can find out the potential similar way. Note it. Next item. This is plus Q, this is minus Q. 2 point charge. Sorry, both the charges are plus Q. Here is another point charge. This is y axis. Here is small q charge, maybe minus, suppose minus charge, negative. At the origin, a negative charge is placed. This is x-axis, y. Follow. If we, this is negative charge, at center negative charge. If we displace the negative charge from the center in this on y-axis slight distance, suppose this is y. So follow. this minus charge here. We placed from O to this point, this distance y. So due to attractive force in this way and in this way, this is theta, this is also theta. If we displace the charge here and release, then it will oscillate according y-axis. It will come to the center, and due to inertia, it will move opposite direction, and in this way, it will repeat. So this type of oscillation, simple harmonic motion. So charge minus q will perform a SHM, that is simple harmonic motion. We have to find out the time period of simple harmonic motion. Clear question? So this is the question. Suppose the displacement y very small, and this distance center from the O, A. So here total field, this is attractive force F, this is also F, this theta, this is theta, this is theta. So F cos theta cancelled each other. Total field 2F sin theta. Total force, sorry, F with the force, F equal to 1 by 4 pi epsilon naught capital Q small q by distance set square. What is the distance? This is A, y square plus a square. Clear? This is the total force. Total force. Suppose this is F dash. So total force F dash equal to 1 by 4 pi epsilon naught Q by y square plus a square. Of course, here 2 into sin theta. Now put the value of sin theta. Here we put the value of sin theta. Sin theta equal to y by sin theta equal to y by root over y square plus a square. If we put the value, then we get QQ by 2 pi epsilon naught y by y square plus a square whole to the power 3 by 2. Clear? This is the if mass of the particle, mass equal to m, the mass of the charged particle m. So this force in downward direction follow F dash and displacement upward. So due to y, we can put here a minus sign because F and y are opposite to each other. Negative sign, F dash and y opposite. Clear? Opposite, that is negative sign. So acceleration F equal to minus QQ by 2 pi epsilon naught m, mass of the particle, y by y square plus a square whole to the power 3 by 2. Next line, F equal to minus omega square y. Clear? This total omega square. So this is the equation of a simple harmonic motion. Now the result will be omega square equal to QQ by 2 pi epsilon naught m 1 by y square plus a square whole to the power 3 by 2. If we put omega is equal to 2 pi by t, and then you will get the result. Follow, y is very small, so y square plus a square from here we can neglect, so final result y square, that is another expression we can get. So you put omega is equal to 2 pi by t and you will get the result. Okay. Now next item, this is plus q, this is plus q, this is another point, midpoint. Suppose this distance 2r, this distance 2r, here a charge q is placed. If this charge is positive, then if we displace this q charge towards this plus q, it will repel, and if this charge move towards this, it will repel plus q charge. So due to these two charges, the plus q charge is in stable equilibrium towards the line. Suppose if this is charge minus q, then if plus q is displaced in this direction, this minus q attract plus q, but plus q repel this plus q. So plus q is also a stable equilibrium. Suppose this type of question, J, two charge plus q and plus q are situated at a distance 2r, and the midpoint another charge q. For the equilibrium of the system, these two charges, for the equilibrium of the system, what will be the value of q and nature? Follow, A, B, force on B due to A equal to 1 by 4 pi epsilon naught q square by 2r whole square. Clear? This direction of course toward in this way. Force on B due to q charge, due to q, 1 by 4 pi epsilon naught q by r square. For equilibrium, the total force on B due to this both two charges will be 0. That is 1 by 4 pi epsilon naught q square by 4r square plus q by r square equal to 0. Because this charge and this charge, if these two charges are in equilibrium, then total force on this charge will be 0. The result will be q equal to minus q by 4. Follow. So nature of the charge minus and value q by 4. If this charge is minus, follow, so result will be minus q by 4. When this charge B is slightly displaced here, this charge will attract it towards the center, but this charge will repel it, so it will move to its original position. Okay, this is called stable equilibrium. So this is the end. You will observe and go through this class, the problems. Of course, the solution of the problem depends on the theory. How every problem there is a theory which is related to it. Okay. So meet you next time in my next class. Thank you.